Hi there, Zach Barron here. This is the CompTIA A Plus Virtual Lab series. I will be skipping over the hardware virtual workbench labs. Uh, if you have an interest in that, leave a comment or send me a message and I can go back and record it. If you're looking to get A Plus certified, I would highly recommend you do all of the labs, of course. I've already got an A plus and I'm working towards Security Plus, so I'm not as personally interested in the hardware side of things. But the first three labs that come up are to configure a wired, a wireless network, and a SOHO, small office, home office router. So this first one, the scenario is that we're working as a managed service provider and modeling a network setup through GNS3. Uh, I've already opened the relevant file and started the nodes. So the next step, we're going to capture packets through this connection here using Wireshark. And so right click, select capture, and it will open up a Wireshark network analyzer tool. Um, and then open up a console on PC1 where it says to do help, which is useful to learn what kind of commands you have available to you if you don't already know. And then it wants us to ping uh, one of the other PCs on this network. You can see that it is working just fine. Um, and so we'll go back over to Wireshark here and select an ICMP frame. Open up Ethernet, and you can see that it asks the question, what sort of address is shown in the source and destination. You see six sets of hexadecimal pairings here. That is an indicator of a MAC address. So we're looking at physical addresses for the Ethernet here. The source address, and I hope I don't have to type all this in, is good. Right there. You can see the source address right here. 050, 79, 66, 68, 00, right? And the destination address is of the other computer that we use the ping function for, which is this one ending in 01. Okay? Next up, we are going to ping, as you recall from the network diagram, three of the computers are set up. One of them is not connected yet, so we're going to ping that one. It will not work because there's no cord going to it, right? Not reachable. There it is. So, um, next up, we are going to go back, and this is, of course, a simulation of running an actual physical Ethernet cable from PC4 to our switch so that it should now be connected to the network, right? Um, and we'll go back to our PC1 terminal, ping that computer again just to confirm that it is indeed connected to the network. Coming back over to Wireshark, you can see at the bottom of our thing we've got our ICMP, our ping that was captured by the Wireshark. You can see here that there was a send, receive, send, receive. So there is our Ethernet address for PC4 is right here. This one is the source because it is the return part of the ping. As you see, initially we looked at the sending one. This is the receiving one, right? So that is connectivity to that one. Run another probe to identify PC3's hardware address, right? It's easy enough. Press up in there, delete 4 and do 3 instead because that is the IP for PC3. And then you can come back over to Wireshark. You can see that it has done the same thing again, and you can get the MAC address of that which ends in 02 here. All right. So that's pretty much it for testing out the Ethernet connections for our wired network. There are some comprehensive questions. Which of the following types is the network we configured? We configured a local area network. In GNS3, the line connecting nodes represents a physical link. In a typical office cabling scheme, we would use a patch panel to terminate cable running through a wall conduit. And a customer wants to know why you're using this expensive switch instead of a cheap hub. And that is because hubs do not support power over Ethernet, they do not support gigabit Ethernet, and their performance is reduced by collisions. And that's it for our wired network. Next up, we'll talk about a wireless network. Okay, so this is our wireless network now. The next lab in the A Plus series. We have a router here connected to an Ethernet switch and two wireless access points, one of which will be used to set up a guest network with a captive portal. So, we've opened up GNS3 and the the Wi-Fi project, and started all of our devices. Next up, we open the PC1 console, and we're going to open up Firefox and we're not going to upgrade Ubuntu right now, sorry. In the address bar, we're going to open the router's interface by typing in the IP address 10.1.1.0.1 and put in our root username and the password. Oops. And the password is password. Of course, I wouldn't recommend using password as your password, but you know, it makes it easier to do these labs. All right, DHCP4 interfaces. Oops, I meant, shoot. Services, DHCP v4, leases. And then we're going to record the IP addresses of our two access points, 10.1.02 and 10.1.112, right? So there's one of them, and there's, okay. Oh yeah, APU, 10.254.02, there we go. All right, and there's our two IP addresses. We're going to open up Never SSL, which is an insecure, unencrypted website that is good for testing basic connectivity. It doesn't use SSL or TLS transport layer security. No encryption, no authentication, no secure HTTP. It's just a basic website to test whether or not your internet is working. We'll close this. I'm going to leave that open and not upgrade Ubuntu still. All right, next up, we're going to connect our laptop. I've already deployed it, but I'll click it again anyway. Going back to GNS3, we're going to open a console for the laptop 1. check our Wi-Fi is not connected. So I need to select a network. We're going to go with the employee network because this is theoretically an employee for whatever this company is. Architects. They must be an architecture firm. I kind of skimmed the beginning. Um, and now we see the Wi-Fi is turned on. We'll open up Firefox, go to neverssl.com, and see if it works. I bet it'll score it before I even get there. Yep, it sure will. So there's Never SSL. We're still not upgrading Ubuntu. Not even on our laptops. All right. Laptop 2, same thing, but this one is a guest. So we'll start a console. Open up that for later, probably. Wi-Fi network, we're going to select the guest network and connect. And their password is Structure Reality. That's a cool company name. I'm actually going to close Firefox and open it again because I bet it won't work right the other way. You must log into this network, and yeah, it didn't do the right button, so I go close it and open it again. There it is. Open network login page. This is the captive portal here. They'll usually have like a password or something, some sort of authentication to verify that you're a guest of this network. This one doesn't. It just requires you to accept the terms and conditions. And then once you have, you're able to go to Never SSL to confirm that you have internet. All right. So you might have noticed that the internet connection from one or both laptop VMs was slow. Use the Lin SSID Wi-Fi analyzer to check the network for a possible misconfiguration, which we obviously have because why else would we be doing this lab? So we're going to go over here. Oh, yeah, I already have the console open. Laptop 1. We're going to open Lin SSID, put in our password, which is password, and that'll open up our network analyzer. I'll go full screen on it. And we can look through here once it starts. Press play first. Can't forget to press play. Once it starts scanning, you'll see it pop up here. Yep, right there. We have two networks. Our employee and our guest networks are both set to channel 1, which will cause interference. So that is why that is the answer to this question here. What's most likely to affect the performance and reliability of the two networks? They're both configured to the same channel. So we're going to stop it, and I'm actually going to close it because the last time I did this, I had to close and reopen it anyways. So if one access point is configured to channel 1, the best channel for the other one to use is the farthest one away, available for Wi-Fi 4, which is channel 11. From the dock, select GNS3 icon. We're going to go back to PC1. I actually never closed it, so I get to skip a couple steps. We're going to open up our router again. Type in admin, and our password is password. Sign in. And here's our thing. We'll go to hotspot. And you can see here's our hotspot. For later, there's a question about this. Come on, scroll down. Am I full screen? Oh, there we go. There's your problem right there. This will be a question later. There's a 5 gigahertz 802.11 AC option available that we're not using right now. In our channel list, we're going to select the farthest one from number 1, which is channel 11. And we're going to save settings and restart, which will take a second. Go back over to our laptop. And we're going to toggle, turn it off, and turn it back on again. Or I'm not, because I clicked the wrong thing. Turn it off, turn it back on again. I'm going to reopen the scanner and run it by pressing play. And this time you'll see that they are on separate channels once it shows up. Here it comes. Here in a second. There it is. All right. So that's it for our Wi-Fi network. We have some comprehensive questions here that I've already kind of talked about. The emulated network hardware used in this topology, an Ethernet switch with separate access points. We saw here router with an Ethernet switch, 2 access points, one of which is set up as a guest network. Which of the following frequency bands was available to use but not configured? I mentioned that in our in this one right here over here. That we have the 5 gigahertz. We have a 5 gigahertz 802.11 AC channel, that frequency band, whatever, that is not being used currently. So there's the answers to those 2 questions there. Score. What? Oh, whoops. My bad. Router with separate access points and Ethernet switch. Yeah. I said the right thing. I clicked the wrong option. So, there's our Wi-Fi network. And next up, we will talk about small office, home office setup. Okay, our last part of this little section is we're going to set up and configure a SOHO or small office home office network. Starting with opening up GNS3, we've got our home router thing. It says what type of port on the router should PC1 be connected to? We should connect it to a LAN port. I'm going to go ahead and do that and start up our PC1. So, our local area network is the port that we're connecting to. Add a link, set it up through Ethernet, and we're going to start PC1 without starting the router, which is important for this lab because they want our network connection to fail the first time we look at it. So we're going to come up here and notice that the adapter is not configured. There might be a failed status. It sometimes pops up, sometimes it doesn't. There is no DHCP server available because our router is off. So we're going to go back to GNS3, turn our router on, and then come back to remote desktop. I will turn off our network and turn it back on again. Hopefully that works. There it goes. Huzzah. And then go into wired settings. Click on the cog to set up our, or look at our configuration. Which of the values shown in this dialog can be used to access the router's management interface? That's our default route, which is 192.168.1.1. And so, next up, we're going to open up Firefox and type in the IP address of our router to open up the management interface. The password has not been configured yet, so we'll just log in as root with no password. Go into System Administration, type in our new password, which is going to just be password. Password, save. And then we're going to log out, score it, and then log back in. I suppose I should wait. There it goes. Then log back in with the same password we just used to verify that that password works. Go into Network Interfaces and look at the configuration of our LAN and WAN interfaces. So you can see we are using our LAN through Ethernet. We have one device connected to it. You can see packets received here, packets transmitted down here, TX. Doesn't stand for Texas in this instance, unfortunately. And you can see WAN interface is connected, but there is no DHCP yet because we haven't connected to the internet, which is the next step. So we'll come over here, add a link from our router, our WAN link to the internet. And then we can come back over to here, refresh the page, and see that, refresh the page one more time to see that our WAN has a DHCP client, IPv4 address. The WAN IP starts with a 2. Oh man, I actually have to type it in this time. 203.0.113.3 is our WAN IP. And just to prove that we can access the internet, we'll come in here to Never SSL. And there it goes. So we'll do the same thing with PC2. I was already on it. All right. Same thing with PC2. Connect it. Start it up. Open the console. And make sure the wired network is working for this PC as well, which it should be once it comes on. All right, there it is. Let's go to Firefox. And neverssl.com, which will take us to an unencrypted, unauthorized, whatever, website. And it works perfectly fine. Score and move on to verifying DHCP. So we'll go back to our PC1 window and go to status overview where you can see there is IPv4 upstream panel representing the status of our internet. Our router is working as a DHCP client. And there is a note here about how the way our lab virtual machines works, it's not actually configured with a public address. That's just because of the way that these virtual labs work. So to find what the IP address is for this one, we're going to come over to a new tab and go to ipinfo.io/IP, and it'll tell us our IP address is this one right here. The public address for it is 168.245.203.246. Right? And there it goes. Close the tab. Status overview. All right. And I'll look down Here, our active DHCP leases, are listed here. PC1 and PC2 have IPv4 addresses and their MAC addresses here. The MAC address of PC1 is the one ending in 0. Oh man, I really have to type in all of this stuff this time. Man, usually if I've already done the lab, it types it in for me, which is great. So this one ends in 00. The other one, let's see, 0C47 BF32. Oh, whoops, I'm looking at the wrong one again. Shoot. 0C EO 825400. Got it. There we go. So there's our, oh my gosh. Reading comprehension, IPv4 address is 192.168.166. It's what happens when you try and rush through this stuff. Take your time, folks. All right, so you can see there is also DHCP v6. We've got IPv4 and IPv6, which means that this is a dual stack setup. You can see here's the configuration of our DHCP server here. Network interfaces is next. We're going to edit the, or just look at, I think this time, I think the next lab is about troubleshooting, changing static to DHCP, for example. But for now, we're just looking. On the General Settings tab, you can see there's the IP address of our router right here, the 203.113.6 WAN interface. We'll come back up to our DHCP server tab. The lowest IP address available is going to be one ending in 100. 192.168.1.100. Okay, and then we'll dismiss that. All right, and so that is our kind of introduction to our networks, wired, wireless, SOHO router. This one has a couple questions about. See, LAN hosts are configured with a /24 network prefix. That means that it is 255.255.255.0 subnet. What technology does the router use to forward packets? It uses NAT, and if configuring one of the PC hosts using static addressing, what dotted decimal should be used for the gateway parameter? This is our router IP address is going to be that 192.168.1.1. So that's it for our first set of A+ labs. I think the next set of them is troubleshooting wireless networks. So if you have any questions or comments or need for clarification, please leave a comment or send me a message, and I'll see you on the next one.